how do we factor a polynomial? The first step in factoring a polynomial is to find the greatest common factor of all of its terms. Then we write the polynomial as a product, which means multiply, right? Product by factoring out the GCF from all of the terms. The remaining factors in each term will form a polynomial with the same number of terms. This relates to dividing polynomials where you never lose a term. A term doesn't become zeroed out by division or multiplication unless 0 is part of that already. So let's factor out the greatest common factor for each of these polynomials. Our first example is a binomial separated by the subtraction. So the first thing that we want to do is find the greatest common factor for 49x and 35. So 49 is 7 times 7 and 35 is 7 times 5. So these do have a factor of 7 in common for the two terms. So I'm going to factor out 7 from this binomial. But if I want to write this as a product, I can't just leave it this way. It'll change the value. I have to also divide 7 to see what remaining polynomial we'll have inside of the parentheses. So for the first term, 49 divided by 7 is 7 times x. And for the second term, 35 divided by 7 is 5. So we factored out the greatest common factor from that binomial. Our second example, we have a trinomial here, 3 terms. So let's see what common factors we have. 14 is 7 times 2, so I can see that there is a 7 in common for all of these terms. They all have an x, so the lowest exponent is 1. And they all have a y, and the lowest exponent is 1. So the greatest common factor here is 7xy. From this trinomial. And in order to write this as a product, we need to divide 7xy to see what remains for each of these terms. Okay, so 7xy being multiplied by the remaining polynomial. So for the first term, 14 divided by 7 is 2. And x cubed divided by x is x squared. And the y's will cancel out multiplicatively. The middle term, 7 divided by 7 is 1. X squared divided by x is x, and the y's will cancel out. For the last term, 7 divided by 7 is 1. X divided by x is 1. Y divided by y is 1. It doesn't disappear. That term is just 1. So this is the factored form of that polynomial. Our third example, we only have 2 terms separated by that subtraction. And so do these 2 terms have a greatest common factor? 6 times x plus 2 and a y times x plus 2. So they do share an x plus 2 in common. So I want to factor x plus 2 out of this binomial. So I have to divide x plus 2 from both terms to see what remains of that binomial. Okay, so let's divide that out, and that's going to leave 6 times 1. And divide that out, that's going to be y times 1. So my factored form is x plus 2 times 6 minus y. Same thing with this other example. There's 2 terms, and the greatest common factor, they have a y plus 1 in common. So I want to factor out that y plus 1 from what we have right now, these 2 terms. That means I have to divide that y plus 1 to see what remains of those 2 terms. Okay, so GCF. And let's see what we get when we divide that factor. It cancels out multiplicatively. It leaves xy. In the second term, if we divide that factor, that cancels out, and That leaves just 1. So we still have a remaining binomial after we factored out the greatest common factor. Factor out the greatest common factor from the polynomial. So here we have 2 terms. Of course, they got to go and put fractions here, so it's a little bit more complicated. If you have any fractions in your polynomial, then you must factor out the least common multiple of all the denominators. So I've got denominators here of 5. So I know my GCF has to have 5 in the denominator. That's the least common multiple of 5. And if I look at the numerator, we've got a 2 and a 1. So the greatest common factor for the numerator is 1. Another thing is that if your very first term has a negative coefficient, then your GCF will be negative. You'll be factoring out a negative greatest common factor because the first term is negative. Always, always factor out a negative if the first term is negative. Okay, so I took care of the negative. I took care of the fraction. What's left? Z. They do have a z in common for those 2 terms, so the lowest exponent is 2. And that makes our GCF a negative 1/5 z squared. So let me factor that out from what we have right now, a binomial here. So I have to divide a negative 1/5 z from each of these terms to see what remains. I'm sorry, z squared. So GCF, let's see what remains here. Negative 1/5 divided by negative 1/5, that cancels out. Z cubed divided by z squared is z. For the second term, when you divide 2/5 by negative 1/5, you have to multiply by the reciprocal. Okay, so multiply numerators, multiply denominators. We can divide out a 5, and that leaves negative 2. And the z squareds cancel out. So this is the factored form of that polynomial. And the reason why we have those special GCFs is so that the remaining polynomial looks much more simple and nice. Remember that when factoring out the greatest common factor from the terms of a polynomial, that should always be the first step in factoring a polynomial. Usually this will be followed by additional steps in the process that we will learn in the next sections of this chapter.